Hello. We have another interstellar visitor to our solar system. This newly discovered object invokes some profound questions. Are we alone? Or are we just bumpers in a lonely game of intergalactic pinball? Avi Loeb, a NASA scientist, puts a 40% probability of alien origin on the interstellar object 3I/Atlas. Why is that? And what is so interesting about 3I Atlas that members of Congress are even considering diverting the Juno probe to intercept it? Could this object be of intelligent or artificial origin? Or is it totally natural? In either case, what could we learn from such an entity? What exceptional qualities make Loeb believe that this particular visitor to our solar system is so special? And what can we learn about our own history here on Earth with the exploration of such a celestial body? Could the investigation and pursuit of this and the other two recently discovered interstellar interlopers provide more insight into the events that have shaped our world, our human species, and our civilization? Join us for this episode of Squaring the Circle as we unpack the data on this cosmic visitor as well as its two predecessors, and look at the significance of these enigmatic objects for humanity. I'm Randall Carlson, and I'll see you in a minute. Well, hello everyone. Welcome back to Squaring the Circle. I'm your host, Randall Carlson, and I'm going to be joined by my co-host for this episode, John Arthur Fiallo. Hello, John.
Howdy, sir.
So you've been doing well since our last recording together?
Yes, sir. And you?
Oh, yeah. Yeah, I've been doing very well. I can always be doing better, but I'm doing very well. And hope to keep that up for another, at least half a century. I might be able to get most of what I would anticipate wanting to accomplish if I could have another half century. Okay. Some of those things we may actually be getting into with today's topic, which is, I think, very interesting because as we are both interested in the much larger picture of our existence within this cosmic domain, we're finding that there's constantly new questions we're being presented with these new questions that raise some really interesting issues. And one of those recently is this discovery of this object. We're not sure what it is yet. We're learning about it, but it's called 3I/Atlas. Now, do you know right offhand where it got its name from? And then we'll get into who discovered. I know it was discovered on July 1st, so it's relatively recent.
3I Atlas. So the 3I is it's the third interstellar object that we've actually tracked. That we're very clear that it's not in any sort of far solar system orbit, and it was actually found by the Asteroid Terrestrial Impact Last Alert System. Atlas.
Right.
On July 1st, 2025. I had to read it over here because that is quite the mouthful.
Yeah, let's read it once over again. It's the
Asteroid Terrestrial Impact Last Alert System. So the I is silent in the acronym.
So, okay, yeah. So when we speak of its name, but we should speak of I. So it's the third,
Interstellar.
The I is interstellar. The third interstellar, not a solar system object, an interstellar object.
Because it's clearly coming from very far away.
Out there somewhere.
Correct.
And it is passing through our solar system, our celestial neighborhood. It's coming in, it's sort of out in the fringes of the suburbs right now as we speak, I believe, and it'll be coming in. And when does it make its perihelion passage around the sun? That is in March 16th, I believe, of next year?
Yeah, I believe so. Let me pull this up.
And let's define perihelion for anybody who's not sure what that means. That is the point at which in its orbit it's passing closest to the sun. Peri means proximal, close to. Helion is the sun. Its close passage to the sun is going to be on March 16th, right? Was I right?
You're thinking about our best opportunity to send a probe.
To probe, yes.
From Juno. So Juno, which is
wouldn't get there till March 16th.
March 16th to 26th.
When
October
is perihelion?
29th is
of
perihelion.
This year.
Of this
October
year.
29th of this year. Okay.
So it's very close. And so it'll be passing just outside of the orbit of Jupiter. And it is going to be, we're not going to be able to see it. We're going to be on the opposite side of the sun.
During perihelion.
During perihelion. Correct.
But we will anti-perihelion and post-perihelion, we will be able to see it, I presume.
Correct.
I mean, we see it now, so we're still going to see it when it's
correct,
well within the orbit of Mercury. Now, it does not. There's no indication that it's going to come within the. I mean, it's more than an astronomical unit away from the Earth, and it's a perigee, right, which would be the closest passage to the Earth.
1.36 astronomical units.
All right. So let's define an astronomical unit. An astronomical unit is simply the distance from the Earth to the sun. So you said it's going to be 1.3. So then that 0.3 would be its distance, its perihelion distance. You could think of it that way, with, of course, some adjustment for the size of the sun, because when that perihelion measurement is given, I presume that is from the sun's, measured from the sun's center of mass, rather than the sun's surface. That would make more sense, wouldn't it? But for round figures, we can say it'll be about 0.3 astronomical units on the other side of the sun. So it'll be 1 astronomical unit from the Earth to the sun, but you said it's going to be 1.3 astronomical units. And because of the fact that the Earth is essentially on the other side of the sun, like if this is the sun and this is the Earth, right? And then we have the object coming around as it's making perihelion, it's going to be pretty darn close to perigee at the same time.
Yeah.
It would have to be.
So it'll be at 1.36 astronomical units from the sun. It'll be at 126 million miles.
Okay.
If you're using freedom units. Yeah.
That makes sense. Because in round numbers, 93 million miles to the sun. And then we would multiply that by, what was it again? How many astronomical units?
1.36 from the sun.
1.36. So times 1.36. Yeah. And what did you say about 126
million miles?
Yeah. That's what I came up with. So, so John and I were on the same page. Okay. So what about this object? Now, I mean, we know it was preceded by, let me see if I can get this, ʻOumuamua.
ʻOumuamua.
ʻOumuamua. Yeah, ʻOumuamua. Okay, that's kind of like Hunga Tonga Hunga. This is ʻOumuamua.
It is Hawaiian. I feel like I'm going to be put out to pasture every time I try to say it. So forgive me, native speakers. But yeah, that's going to be something we stumble over. And Borisov, 2i Borisov. And so both of these were very, very interesting. And in fact, I can actually pull up a graphic that shows both of their trajectory here. Give me just a moment. And I can pull this up really quick. So here we have, this is courtesy of Wikipedia, but ultimately I believe this is from JPL.
Yeah.
So the red line, if you're on the audio, I apologize, but ʻOumuamua comes in at a very acute angle and passes very close in our solar system, and that was the first one in 2017. And then Borisov, 2i Borisov comes along at this very obtuse angle.
Yeah. So let's look at those angles. So it's looking to me there like, okay, look, when the two objects are making perihelion, ʻOumuamua is much closer to the sun than Borisov. Well, then that is affecting the shape of their orbits there, because what's happening is that powerful gravity field of the sun is pulling ʻOumuamua in and wrapping it around close, whereas the effect on Borisov is much less, because Borisov is outside the orbit of Mars, so it's quite a ways from the sun. So its gravity field is not going to distort its orbital trajectory nearly as much as we see happening with ʻOumuamua.
Correct.
Now, where, by comparison, where will, let's see, you said that, where does Atlas fall?
You'll actually see it's 5% within the plane of the ecliptic.
Yes, which
is interesting.
Mm-hmm. Now let's clarify that. Plane of the ecliptic is going to be the Earth's orbit around the sun. As the Earth orbits the sun and sweeps out a flat plane, that's what we call the plane of the ecliptic. So called because the eclipses only occur when the moon is precisely crossing that plane, the flat field of Earth's orbital plane. Think of it as just a two-dimensional plane, and Earth is orbiting. But kind of perhaps coincidentally, the moon's tilt relative to the plane of the ecliptic is 5 degrees. So it's essentially the same as Atlas's angle of the ecliptic. Not that that has any significance or meaning to it, but I just note that it is tilted at the same angle as the moon is to Earth's orbital path, which is called the plane of the ecliptic.
And so I think hearing a quick excerpt from Avi Loeb, and then I think we should dig into the news on this would be appropriate, because Avi Loeb is a researcher and scientist, and he's made some really interesting claims. But I think it's, you and I were talking about this beforehand. I'm not going to spoil too much. This is a interview that he did on CNN. So,
okay.
Okay, so we're bringing in Harvard Astronomy Department Chair Avi Loeb. Thanks so much for being with us. I want to start with this thing we're talking about, the 3I Atlas comet. NASA's like, look, it's got an icy nucleus. It's got that cloud of gas and dust. We've got the Hubble. We've got the Webb. These telescopes have shown that there's no strange signals, no maneuvers, nothing artificial. Why do you think it could be artificial or alien technology?
Which is it?
Well, the brightness, thanks for having me, by the way. The brightness of the object implies a diameter of 20 kilometers. And there is not enough rocky material in interstellar space to deliver such a giant object per decade. It takes 10,000 years for that much mass to arrive to the inner part of the solar system. Moreover, the trajectory of this object is very fine-tuned. It lies in the plane of the orbits of the planets around the sun to within 5 degrees. The chance for that to happen is 1 in 500. And moreover, it passes very close to Jupiter, Mars, and Venus, with a chance of 1 per 20,000 if you just change the arrival time randomly. And it will arrive closest to the sun when the Earth would be on the opposite side. We won't be able to observe it, but that's the perfect time for it to maneuver. And so we just need to watch it. I'm not saying it's an alien technology. I'm just saying it doesn't look like a very common thing. And actually, the glow that is around this object, usually for comets, you see a trailing tail behind the object. And here, the glow from the Hubble Space Telescope image is actually in front of the object. We've never seen such a thing. A comet doesn't have glow in front of it.
But can you tell me why your position on this is so different from NASA's, and why in your paper about it, you kind of talk about this as a thought experiment, a pedagogical kind of exercise. You're casting doubt, and then NASA is saying it's not true. So why keep talking about it this way?
Well, science is about asking any question that you like. It's not there is no censorship on the type of question that is being asked, and the scientific method is about using data to select the correct answer. Now, assuming in advance that you know the answer is not a productive approach. We need to collect enough data, and there should be a scale that classifies objects between 0, where it's obvious that they are natural, when there is a cometary tail behind them, they don't have a special orbit, there is nothing unusual about them, and a 10, when it's definitely an artificial object where it maneuvers, there are some artificial lights, and we should look carefully at any interstellar object that comes into the solar system. We're in a new era now that the Rubin Observatory in Chile will find a new interstellar object every few months. And I'm suggesting to leave all possibilities on the table, because we launched probes to interstellar space, Voyager, Pioneer, New Horizons. And why should we assume that we are the only one in our cosmic neighborhood? We should just check by looking at data. It's not a matter of opinion. It's not a matter of NASA having authority on this matter.
And I hope to see that data soon. Avi Loeb, thanks so much.
So I love the fact that he says, hey, this is what science is. It's about getting an abundance of opinion.
Well, she says, why do you keep talking that way? Look, NASA has declared omniscient, all-powerful, all-knowing NASA, has declared that there's no evidence of it being artificial. So why do you keep talking about it this way? Well, I'm not endorsing the idea that it's artificial. Of course not. I don't know. But he's pointing out that this is a unique object. It's an enigma. It doesn't fit the pattern. It's something, like he said, we've never really seen anything quite like this before. So it naturally raises questions. But this is typical CNN. I mean, this is typical mainstream media here. Well, why keep talking about it this way? We've got NASA. Well, okay, so I don't know, what is it, over 100,000 employees in NASA? I'm just curious. How many employees in NASA? Probably out of the whole panoply of NASA employees, there's 2 or 3 guys, maybe just one guy, who's doing the scientific research on this, has concluded it is more likely a comet of some kind, an unusual comet, which is what I would be inclined to believe. But, Avi Loeb, he's a theoretical astrophysicist. He's a cosmologist. I mean, his take on this is of value. And she's like, oh, well, why do you disagree with NASA? NASA has given the final word on this. There's no mystery. Let's just move on. And he says, well, no, there's all kinds of things. And we're going to look at some of those things to try to get a better handle on this. Now, ground news is what we've now started using for our research into current events and topical questions like this one. And we will talk about ground news because I'm really excited about using ground news as another research tool. But so we've got ground news up here, and we've got the heading from Harvard professor believes interstellar comet could be alien spacecraft. Well, is that the same? Is this Avi Loeb?
It's Avi Loeb.
Okay, so we just heard from him, and what we heard does not support this headline. He says, now, I'm not saying, or I don't believe that that's what it is, but we have to be open and consider all possibilities because we've never seen anything like this before. But this headline here is misleading. Now, do we know the source of this? This is from where?
So this is an amalgamation of a couple of different sources. But if we go to the bias comparison here, we can look at how left-leaning and right-leaning outfits actually use and filter the data into their headlines and how they run. And that's why it's actually really cool to have them on as a sponsor. They actually reached out to us. Mm-hmm. And we're actually really, it's exciting to use them as a tool.
And already it's proving to be exceptionally valuable and time-saving.
And then the other thing that you and I were playing with, Randall, was the blind spot tool.
Yeah, which I really like. Because, I've thought all along, and I have not put it in those terms, I've thought for years, guys, there's a blind spot on the left. They just don't see this stuff. And then same thing on the right. Now, lately I've been more sympathetic to the right. Let's say, in fact, that turning really, I think, shifted into Clinton years. But still, I'm critical of the right, and I think they have their blind spots. And that's why I choose to be an independent and look at both sides, because I think I have developed enough discernment over the years of my life that I can tell when something is credible and when something is not credible, when somebody is ignoring evidence, when somebody is endorsing a particular point of view. But still, having that definition set out like we're doing right here really is helpful. I mean, it really helps to define that you do have these two dominant perspectives in American political and public life. And what it appears to me Ground News is doing is making it very straightforward to instantly be able to see where on the political spectrum some story is originating.
Correct.
Right? Because why? Well, why is this valuable? For one thing, that is, I think, critical to being able to help people see through propaganda, to know where it's coming from, right? And we just saw this clip with this interviewer with Avi Loeb, and I made the comment to you that appears to be typical CNN. And we know where CNN is falling on the spectrum. But now there's a lot of, I think this is an organic movement. I mean, we'll look at this. We've got so many different, let's look at some of the ones that they're representing here.
You've got Trump having a discussion on the plight of children in war. Only 8% of the reporting sites were on the left, whereas on the right side, Trump's discussing Sean Hannity's relationship with Ainsley Earhart, and you have 0% of the right-wing media reporting on it, whereas left and center comprise the whole. So if you are in a silo, this is a great way to get out. And right now, if you guys use the code here on the screen right now, or the one down below in the pinned comment, you can get 40% off of Randall's Vantage plan, the one that he's been using for the last couple of months.
Yeah, and as I'm getting more and more familiar with the tool here and the power of this tool, I'm finding myself using it more and more frequently. I'm adding it to, I use Google Scholar as a research tool. I use ResearchGate, several others that I find to be very helpful. Trying to track down stories and get different perspectives. So this now I've added Ground News, particularly, with breaking events that I'm interested in researching, like the one we're talking about right now. Anyhow, this paper that you downloaded from Is the Interstellar Object Alien Technology? There it is. Let's go through. There's some of the points that this has got to be the same guy, right? Abraham Loeb with Harvard University. Yeah, it must be this. It must be Avi. Is Avi a contraction for Abraham?
Yeah, it is the same fellow.
Same guy. Yeah, there we are. Just looked him up on Wikipedia. Abraham Avi Loeb. Avi in quotation marks. So that's kind of a contraction, a nickname. Loeb is the Frank B. Baird Jr. Professor of Science at Harvard University, where since 2007 he has been director of the Institute for Theory and Computation at the Center for Astrophysics. He chaired the Department of Astronomy from 2011 to 2020 and founded the Black Hole Initiative. I am not familiar with the Black Hole Initiative. Are we going to mount an expedition to a black hole? Is that in our coming up here? I don't think that's
first worldwide center to focus on the study of black holes, a collaborative interdisciplinary collective, is the harvard.edu slug.
Okay, so let's look here. He says, in the abstract, at this early stage of its passage through our solar system, 3I/Atlas, the recently discovered interstellar interloper, has displayed various anomalous characteristics determined from photometric and astrometric observations. as largely a pedagogical, I think it's pedagogical exercise.
Pedagogical.
Yeah, in this paper, we present additional analysis into the astrodynamics of 3I Atlas, and I think from now on I will just refer to it as Atlas, and hypothesize that this object could be technological and possibly hostile, as would be expected from the dark forest resolution to the Fermi paradox. We talked a little bit about that before the show, and
So the Fermi paradox, I think we should start with the Fermi paradox, which is the idea that, hey, there's a lot of space. Why are we the only ones? Are we the only ones? Does that make sense statistically speaking? And then the dark forest resolution to the Fermi paradox is, well, if there were advanced civilizations and they all had the proclivity to conquer, would they really be interested in broadcasting their presence, or would they work through spy satellites, probes, etc.? And this is where Avi Loeb's coming from. Could this be a tactically disguised probe that's just passing through the solar system? And are the emissions of hydroxyl a form of station keeping fuel, something that looks like it's a comet or asteroid, but it's acting in a very, very unusual manner? And the fact that it's on the plane of the ecliptic, it's going to come right by us while we're on the opposite side of the sun. You know, he's saying, hey, I'm asking questions. That's all he's doing. What show was that? I'm just asking questions. That's what Avi Loeb's take is here.
I'm just asking questions. That was a show.
There was a show
where somebody was asking questions. Yes, there was. Goes on to say here, we show that Atlas approaches surprisingly close to Venus, Mars, and Jupiter, with a probability of less than or approximately 0.005%. That's 1 part in 500, I guess, right? Furthermore, the low retrograde tilt of 3I Atlas's orbital plane to the ecliptic offers various benefits to an extraterrestrial intelligence, since it allows the object access to our planet with relative impunity. The eclipse by the sun from Earth of 3I Atlas at perihelion would allow it to conduct a clandestine reverse solar oberth maneuver, an optimal high thrust strategy for interstellar spacecraft to break and stay bound to the sun. Now let's go into a solar oberth maneuver. Do you have something on that?
I watched it on Star Trek. It's what they did with the Enterprise, right? The fourth movie, the Oberth maneuver. You don't remember? You don't remember the original the
the
fourth
movies.
movie? Yeah. Where they did an Oberth maneuver.
I don't remember that. I remember. Did I see the fourth one?
Was it the fourth or the fifth one where they had the whales? It was the one where they had the whales, and
I did see that
travel. They were trying to the Oberth maneuver is where you fly into a nexus of gravity orbiting the sun, or say Jupiter, which we'll talk about in a little bit. But that's where you're traveling close enough to the gravity that you can use it as a slingshot.
As a slingshot, yeah.
The slingshot maneuver is the layman's term that I'm more familiar with.
It's a technique used in space travel where a spacecraft accelerates while falling into a gravitational well, such as a near planet. And the thing is, if my understanding is correct, this high rate of speed of Atlas is going to make it especially suitable for an Oberth maneuver when it transits perihelion.
Mm-hmm.
It can use the sun's gravity to accelerate it?
To accelerate back out, yeah.
Back out. Okay, this method is more efficient for gaining speed compared to accelerating outside of a gravitational field as it takes advantage of the spacecraft's higher velocity at that point. We will mention that the perihelion is the highest velocity in an orbital system. That because as it's falling into the sun, it's getting drawn in closer and closer. The gravity field of the sun is having more and more effect, and that effect manifests as an acceleration in its orbit. Once it crosses that perihelion passage and continues out, it's now moving away from the sun, right? So now the gravity field of the sun is pulling it back. It's wanting to put the brakes on, right? What the Oberth maneuver is they're using that acceleration as it falls towards the sun to slingshot it, as you said.
And as it gets closer, it'll slingshot out. Now, if this is naturally occurring, then it is just a very, very interesting passage, very unlikely. So my question is how often does this actually happen? How many interstellar objects do we have? We obviously don't have 20-kilometer wide objects passing through every day, but we have like the Tard meteor stream, which is a local phenomenon.
Yes.
Some scientists have thrown out potentially up to 10,000 interstellar objects passing through our solar system. Some of them the size of a rock you could throw, and some of them much, much larger.
Oh, okay.
So
but this one is unique.
It's unique.
Possibly.
It's big. As far as observation goes, it's very unique. There's a coma, right? There's a center nucleus that is glowing, but there's not a heck of a lot of a tail right now.
Right.
And so that makes it interesting, because as something gets closer to the sun, what happens to the ice and to all the volatiles, Randall? What happens to a comet as it gets closer to the sun?
They sublimate, and then they outgas, and they form that tail. So
it's evidence of something burning, whereas or sublimating, right, as it gets closer to the sun. So the question is, why is this so big? And we're going to get into the water volatile issue in just a little bit. How massive is this in terms of volatiles on the mass? But also, B, why is it not showing the tail that NASA would have expected it to show?
Mm-hmm.
It's interesting.
So what we have here, that graphic you just had up, that shows the orbital trajectory of 3I Atlas as it's coming in. We see that outer orange or yellow ring is Jupiter, and it's coming. We see that it's coming within the orbit of Mars. And now this is actually okay. If we look, we see that the object is right up towards the upper right, and that's basically now, correct? At
More
present.
or less.
And then so in October, it's going to be passing down there. It'll be passing very close to Mars. Mars is moving. If you look at Mars on that orange circle, it's moving counterclockwise as we're looking down on it. And you can see that Atlas is moving the opposite direction. So we would say that Mars is in a prograde and Atlas is in a retrograde motion, which means that it's really moving fast through the interplanetary zone.
You had a great analogy to describe prograde and retrograde from the perspective of someone driving in a car.
Yeah.
For those who are not familiar.
Well, it's like you're driving down a highway, and you're in one direction, you've got cars coming in the other direction, and let's say you go to pass the car in front of you, right? Well, assume that the car in front of you is a planet and it's moving forward in a prograde, and you pass it, right? I recently watched another analogy that will kind of fit this as well, is that one of my old-time favorite movies back from the 80s was called The Lone Riders. It was about Jesse James and the younger gang, And there's a scene in there where they're going to rob a train. And it looked to me like the actual actors up there galloping their horses, right? So they gallop up alongside the train, and they get going so the horses are galloping almost as fast as the train is going. They're able to lean over, grab on, and jump into the moving train, right? Well, that, you see, would be like if Comet Atlas or Atlas was in a prograde, it would be moving the same direction around the sun as all the planets are. But now imagine that Jesse James is going to rob the train, but he's riding the horse in the opposite direction that the plane is moving. Well, he's not going to have nearly the easy time jumping onto the train because now you've got to add the velocity of the horse galloping to the velocity of the train moving in opposite directions, right? So what we have here is that this object is going to be in a retrograde orbit. Now, I'm still trying to wrap my head around what does that actually mean? Well, it means it's going to zip through mighty damn quick. We've concluded that it was 60,
over
highest,
60 kilometers
we
per
saw,
second.
Yeah, we saw one estimate there where it was 64 kilometers per second.
That's blistering
64
fast.
kilometers. And what does that work out to be in miles per hour? Well, we calculated that a little earlier. I can obviously do it again. If I go 64 kilometers, I go times 3.28.
It's 136,000 miles per hour. And so this is where I think it really becomes relevant to all of your work is how often do we get baseball size or car sized objects like this coming through, even if it's not the Tard meteor stream? What would a vehicular sized asteroid coming through at 136,000 miles per hour, what would that do to a small coastal village?
Oh my God. Yeah.
Even if it impacts the water, what's it going to do? So the question is, we've got our model of the Oort cloud. We've got our, the Kuiper disk. The next question is, are we in a larger set of streams?
Yeah.
And something that's worth exploring.
I agree. And are we, like Avi Loeb said in that interview, this is a whole new frontier for us. So let's see. Hypervelocity impact involves the projectile moving at very high velocities, such as asteroid and meteorites. The energy associated with the impact load is a function of the mass and velocity of the impactor. So those are the two primary things. The energy released is going to be a function of the velocity. And an analogy I use there is that, let's say I had a 38 caliber bullet, all right, out of its shell, just a 38 out of its casing. And I've just got a 38 caliber shell, caliber bullet, little lead bullet, and you're standing across the room from me and I throw it at you. And I throw it really hard and it's moving 50, 60 miles per hour. I don't think it's going to be moved fast as a Major League Baseball pitcher throwing a ball at over 90 miles an hour. But let's say I throw it at you even as hard as I can and it hits you and you go, ow. Hey, but it's not going to do any damage, is it? But suppose I accelerate that to 2,000 feet per second, which is the speed of pretty much a high-powered rifle bullet. Now look at what that little lead bullet will do to you when it strikes you. And the only difference, not even no difference in mass, only difference is in velocity. And now that energy that's released could kill you. Right?
Correct.
So,
Correct.
So this thing is moving. I mean, if it was to strike something, I mean, if an object, if it's on the high, and we don't know, I'm going to be really curious in monitoring this because I'd like to know really how big this thing is. But if Avi Loeb is correct, it could be upwards of 20 what was it? You said
20 kilometers.
20 kilometers is going to be about 12 miles in diameter. Well,
Yep.
12 miles in diameter, that's twice the diameter of the KT impactor. And we know what that did. And of course, I don't know the shape of this thing, but unlike ʻOumuamua, which looked like a cigar, this thing may be more spherical. But you know, the sphere, the volume of the sphere scales by the cube of the radius. So,
For those who haven't seen ʻOumuamua, looks something like this.
there it is. Yes, look at this thing. Now that was a weird looking thing, wasn't it?
So that was one eye. The first one that we're familiar with is ʻOumuamua. Borisov was kind of simple, and then ʻOumuamua was just a general asteroid, nothing too unusual. But ʻOumuamua was very interesting. It's like this. Atlas. It's unusual in shape. It looks like it's young. It looks like it hasn't been chipped away. And so, just for fun, one more for you.
Okay.
If we have a 1 mile wide iron asteroid, let's say it hits New York,
Bye-bye, New York.
37-mile wide crater,
Oh, man.
70-mile wide fireball,
70-mile wide fireball. Look at
126 decibel shockwave, and you have 9.0 magnitude earthquake. So that's just 1 mile. And so, you know, try 12 for a moment and see what that looks like.
That would be pretty much, that would probably
In-game.
sterilize the planet.
That would be an in-game event.
End game event. There might be microbial life surviving. I don't think any of higher life, probably the whole 90% of the food chain is gone.
Correct.
From an object. And then again, how fast is it moving? What was the velocity of this?
136 miles per hour. 136,000 miles per hour. 136K. There we go.
Oh, yeah. And chances are, though, they're not going to be moving that fast. What makes this enigmatic is that high velocity, which is, 5, 6, 7 times faster than normal objects. We see comets tend to move faster than asteroids. But, we might be looking at, 15 miles per second. 15 miles per second as compared to 60 miles. So it's 1/4 the velocity of this thing, roughly, ballpark.
So the other thing that makes this enigmatic, and you and I calculated this before, we found this through ground news, actually. Water detection in Interstellar Object 3I Atlas. Remember, you and I were doing some computations before on how much water was coming off of this thing. Based on what you and I read here. Did you write that down by any chance?
I believe I did. Let's see.
We're talking a significant outpouring of water. And this is where Avi Loeb is saying that this is an interesting object because it's outgassing at a very high rate.
Let's see.
While you look for that, the detection of OH emission prior to any cyanogen, CN, detection is unusual and may reflect differences in grain-driven outgassing or volatile inventory compared to a typical comet, which makes it unique, worth studying, I think. So how much water is this thing pouring off?
Right. Let's see. Oh, okay. We did calculate that. Works out about 3,500 tons per day. About 3,500 tons per day of water. So if I go 3,500, see, 3,500, I divide that by 24. That's about 145 tons per hour
of water.
I'll divide that by 60, and that's about 2.5 tons per minute.
So what is this thing? It has to be young. It has to be young, or it had to start off as massive. for there to be this much volatile material. Normally, volatiles, compounds that are going to outgas or when they're exposed to the sun, normally they're a sign of age or addition, or that much water doesn't typically, you can't pour out that much water for long. That's a lot. So where is that water coming from? And I think it's a reasonable question. We should ask, is this thing very young or is this thing unusual?
All right, so here we go. This is the evidence, 9 different discrete pieces of evidence that define this object as being enigmatic. And we'll go through some of these here. The first one is the fact that the orbital plane lies virtually in the ecliptic, though retrograde. I equals 175.11. So that would then be, if we subtracted that from 180, that would give us the inclination of the orbit, which is what that I stands for. So actually, if we did 180,
it's 4.89 degrees.
4.89 degrees, so a little bit less than 5 degrees. Okay. And he says here about this that taking the first row in table 1, it appears that besides the fact that it is clearly a hyperbolic trajectory, let's just talk about that for a second, because a hyperbola is one of the family of conic sections, along with parabolas and ellipses and circles. In nature, we don't find any orbits that are perfect circles. Some of them are, orbits are, at least in the inner solar system, and when you mentioned a torrid shower, the torrid meteor stream earlier, they're all in elliptical orbits. An ellipse is a geometric figure that's closed, right? So if we look at an object, a meteorite, a comet that's in an elliptical orbit, we know it's closed, we know it's going to be coming back, right? But a hyperbola is not closed, it's open, and apparently has no closure at any point. So if an object is on a hyperbolic orbit, it's going to come in, but it's not going to close that loop and turn around and come back. It's going to just simply come in. It's going to have its pathway, its orbital trajectory modified by the gravitational attraction of the sun or Jupiter or any other gravitational object that it passes in the vicinity of, is going to affect to a greater or lesser degree its orbital path. A hyperbolic orbit is what we have here. So it's not something that's going to go out and then presumably come back, unless the ellipse is so huge that for all practical purposes, it is not coming back within the life of the universe. Anyways, so what he's saying here is that it is clearly on a hyperbolic trajectory that possesses a non-zero speed at an infinite distance from the sun of approximately 60 kilometers per second. There is a further extremely unusual feature of 3I Atlas's trajectory, which is that its orbital plane is tilted only slightly from the ecliptic and is retrograde. This means attempts by humanity to intercept it, or even more difficult rendezvous with it, are extremely challenging, if not impossible, with chemical rockets. Yet nonetheless, as we shall see, allows 3I Atlas to intercept certain key target planets with relative ease. So again, the idea, we want to intercept it, it's like, Jesse James riding the wrong way down the railroad tracks. You're going to have a hard time leaping onto that train car to rob the passengers or the strong box with the money in it, or the gold, or whatever it might be. So that's what he's saying here. It makes it very difficult for us to actually intercept it. But then it does allow it to intercept certain key target planets with relative ease. Furthermore, a low ecliptic tilt at a distance from the sun would enable an extraterrestrial, an ETI, an extraterrestrial intelligence through astrometric measurements to determine the orbits and masses of the solar system planets, allowing it to prepare an optimal approach strategy to the solar system. So, I mean, from that perspective, you could almost think of it as a, like what would you call it, a recon satellite?
I think that's what Loeb is suggesting.
Yeah. Now, he's saying, of course, that he doesn't really even believe that, but he's just doing it as a pedagogical exercise.
40% is a strong, 40% certainty is a strong number.
And the likelihood for such a perfect alignment of the orbital angular momentum, the angular momentum vector around the sun for Earth, and 3I Atlas is 2 times 10 to the minus third, so 2 over 1,000. So about 1 part in 500. That's and an interesting formula here. It's pi, then it's got the inclination of 5 degrees divided by 57 degrees, and I'm not sure why that is. I'm going to have to look into this. But that division of 5 over 57 is then squared and divided by 4 pi, and that gives you the odds. Yeah, missions to Atlas would have been much easier had the interstellar object been traveling in the ecliptic plane prograde, obviously. Figure 1 illustrates opportunities of to 3I Atlas expire by the year end, and even then would only be achievable for a SpaceX Starship refueled in low Earth orbit and a spacecraft payload with nuclear thermal propulsion. And so you've got thus so this graphic here, since we just downloaded this paper, I haven't had a chance to study it yet. We have the color contours of characteristic energy, C3, for direct missions. Okay, so what this is doing is showing us the potential launch windows.
Correct.
Yeah, and so it looks to me like launch date after July 2025 starts to disappear rapidly. I think that's what this is showing us.
Yep. Your X is your time and your Y is your flight duration.
Mm-hmm.
And if you're on audio, my apologies. You'll just have to look at this on the video. But you're looking at the colors, 14 kilometers per second. 14 kilometers per second squared. Yeah, and then negative to the -2. It's intense.
Yeah, so we've got this, and that is going to rapidly, that intercept window is rapidly going to close. I think that's the key here.
That there's only one vague long shot at getting this done, and I don't think it's going to work based on what little bit of knowledge I have. But Rep. Anna Paulina Luna actually suggested this, as you know.
Okay.
And so she suggests that the Juno probe potentially be retasked because it's going out and it's going to pass by Jupiter on its way out. And that's the March 16th date, 2026.
Right. Okay.
Is our best shot on that mid-March. So she finishes her letter. It is recommended that NASA conduct a study to assess how much fuel is left in Juno's engines, and I support the extension of the Juno mission at least until mid-March 2026 at a cost of about $15 million per 6 months from current expiration date of mid-September 2025. The exciting new goal to study 3I Atlas will rejuvenate Juno's mission and extended scientific lifespan beyond March 14th, 2026.
Mm-hmm.
Even if Juno's engine cannot be reactivated, Juno can gather unprecedented data from 3I Atlas from its current orbit around Jupiter.
Okay.
So here she has it at 65.9 kilometers per second.
Okay.
Is the speed.
Well, and this was when? Because
she
like
put this out on the 1st of August.
Okay, so this is probably an update because it's going to be accelerating as it moves in towards perihelion.
Correct.
So, I mean, this...
Yeah, so this is her X post, and there's a reader's note here. Readers added context they thought people might want to know. As of July 4th, 2016, the Juno spacecraft had 785 kilograms of propellant on board with its 1,593 kilogram dry mass and a hydrogen NTO specific impulse estimated at 339s. The spacecraft had 1,332 meters per second of delta V left at that date, well below the 2,675 meters per second required for Rep Luna's proposal. So that's what the internet is responding with. They're saying, hey, you can get close, but not as close as we would want.
Right.
So there are proposals, though, to loft other craft to be ready, because we had 2017, I believe, was ʻOumuamua.
Mm-hmm.
Borisov was in 2019, if memory serves, and then of course we have this in 25. So Atlas is in 2025. So how many of these objects are flowing through, and what kind of effect have they had on Earth, if any?
Mm-hmm.
Questions that make you go,
Yeah. Well, let's see what in this paper they go on to say that. So, aside or apart from the hypothesis proposed already, which is the idea of an alien spacecraft, two distinct yet natural incarnations present themselves for this object. One, it can either be an asteroid or a comet. Those would be the first things, being more, parochial, if you will, without going into the exotic realm of alien spacecraft. The two main choices of what it would be an asteroid or a comet. If it's an asteroid, and you assume a standard albedo, which is the reflection of the light off the surface of the asteroid, and given how much light we've seen reflecting off of it, which is quite a bit, relatively speaking, then the object must be around 20 kilometers in diameter, and that's the 12 miles in diameter. If, on the other hand, it's a comet, in which case the object would be surrounded by a fuzzy coma with a much smaller nucleus. However, as he goes on to say, both of these natural explanations present difficulties. In the first case, because the prevalence of interstellar objects of size 20 kilometers it should be much lower. Like if we look at this spectrum of things that potentially pass through the solar system, near-Earth crossers, collide with the Earth, what we see is that it's an exponentially declining curve. So that the reverse of that is that, the smaller it is, the more the curve is up here, and as you go down and you get to the larger and larger objects, that curve is asymptotically converging on zero, right? So what he's saying here is that 20-kilometer object is going to be extremely rare. There's not a lot of those. So, or is this telling us there's more than we thought? We don't know, because let's see, we did get the diameters of Borisov And actually, it's hard to say diameter for ʻOumuamuas because it looks more like a cigar. It's more like a cylinder. Anyways, it says here that ʻOumuamua was 2 orders of magnitude smaller than Atlas.
Yep.
This then implies the visit into our solar system of Atlas should be an exceedingly low probability event. And that's if it's an asteroid. If it's a 12-mile asteroid, that's an exceedingly rare event. But then again, it's kind of like Shoemaker-Levy 9. How do you estimate the probabilities of something if you only have one example to work from? Right? Now, in the second case, where it's referring to it if it's a comet, there has been to date absolutely no sign from spectroscopic analysis of cometary activity. Such activity would imply a much smaller nucleus and allow Atlas to be drawn from a much larger interstellar population. We await with anticipation further observations of Atlas, which should clarify the situation. The fuss observed around 3I Atlas is inconclusive given the motion of the object and the inevitable smearing of the image over the exposure time. Then let's see if we look at the next one. Yeah, there we go. So if we, right there, we see how close the closest approach to Venus, 0.65 AU. So we can simply, all we have to do if we want to calculate, you listeners at home, if you've got a calculator, pull it out, put in 93 million and just times it 0.65 and you'll get, my light is poor here, you get about 6 million, just over 6 million miles from Venus. And then Mars is very close, 0.19 in the cosmic sense. Closest approach of Atlas, and you've got the minimum possible closest approach. And Jupiter, 0. What is that suggesting? That it could potentially impact Jupiter?
That's what it's suggesting. It's within margin of error.
Pertinent parameters concerning the alignment of Atlas with Venus, Mars, and Jupiter. Maximum possible. Okay, but 0, man, how did they get that? I mean, isn't that implying that it would
Potentially.
That it could actually strike Jupiter?
If you had a 12 mile, 136,000 mile per hour impact into Mars.
Whoa. That
would shake things up.
My God, wouldn't it though? And there it's showing minimum possible closest approach of 3I Atlas, 0.000 to Mars.
The probability, though, is very low that it hits anything. It's just going to zip through. But there is a small chance, I think is what they're saying.
Yeah. A small but finite, very, very small. Let's see. In fourth in table 1, we find that Atlas approaches particularly close to Venus, Mars, and Jupiter during its visit. In the following analysis, we assume that 3I Atlas is on its current orbit, but vary the time of entry into the solar system, or equivalently the time of perihelion, assuming 3I Atlas could have come at any time into the solar system and happened to do so such that it came within the observed closest approaches of Venus, Mars, and Jupiter. The probability of this is 0.005%. 1 part in 500, I believe, right? We further assume that the closest approach of 3I Atlas to the planet is entirely a consequence of its difference in heliocentric longitude, which basically just means where, if you think of that plane extending out from the sun, heliocentric means centered on the sun. And think of your longitude on Earth as being your east-west way of defining position. That's all that it's saying there. The 6th column on table 2 provides a degree of misalignment in longitude between the planet in question and the interstellar object at its closest approach, the sixth column on table 2. Oh, I see. That's the one we were just looking at. We'll skip the calculations for now. So referring to the 6th row on table 1, which is the optimal point to do a reverse solar oberth and stay bound to the sun. Referring to the 6th row of table 1, we find a possible motivation, since the optimal braking strategy is to stay bound to the sun for high thrust propulsion is a reverse solar oberth, where all the thrust is imparted at perihelion. Thus, any maneuvers of this kind would be obscured from Earth observation, allowing a surprise arrival on Earth to be conducted.
Oh, here he comes out and he says what he's thinking.
Yeah. Wow, the 7th row of table 1, which maybe go back to that.
I'm
table.
heading up there. Here we go.
Okay, so the 7th row, it says, incoming radiant made it hard to detect sooner. So what he's saying here, and this is interesting, is that the 7th row in table 1 reveals a curious feature of 3I Atlas's apparent direction of origin, in that Atlas's incoming radiant to the solar system was from the direction of the galactic center, a particularly bright region which, as has been noted elsewhere, made the object particularly difficult to discern by Earth-based telescopes, in turn rendering it less conducive to early detection. The relevance of this is that had the object indeed been discovered earlier, then there would have been some possibility that humanity could have mounted an intercept mission, a recourse that was out of the question by the time 3I Atlas was actually detected. Figure 2 shows the optimal intercept trajectory for a mission to 3-1 Atlas with optimal launch over a year ago.
So there's we missed it. There's an old World War I saying, "Beware of the Hun and the sun," is what the British pilots would say, because the Germans would fly as that they would strategically position themselves above the Brits and then come flying out from apparently the sun. So that's what he's inferring here. This is a alien tactical strategy. It's an interesting theory. Color me skeptical, but it's interesting. So this would have been the optimal direct mission to intercept 3I Atlas. Depart on July 19th and intercept. So it would have been a very, very short meeting with a 93.2 kilometer per second relative velocity. You have 1 nanosecond to take your photograph and do your scans. But you would have gotten something. So what do you think, Randall?
Well, I'm still making up my mind. So looking back at the table there, the delta V needed to intercept Jupiter is small. The delta V needed to intercept Mars is small. Well, yeah, we've just determined that. So that's 8 and 9 on his list of 9. 7 is Atlas's incoming radiant. Made it hard to detect sooner. I'm still going to have to look into this reverse solar oberth. I want to know about that.
So he's got a conclusion here. We strongly emphasize that this paper is largely a pedagogical exercise with interesting discoveries and strange serendipities worthy of a record in the scientific literature. By far, the most likely outcome is that, or most likely outcome will be that 3I Atlas is a completely natural interstellar object, probably a comet, and the authors await the astronomical data to support this likely origin. Nevertheless, when viewed with an open mind, or from an open mind, and unprejudiced perspective, these investigations have revealed many compelling insights into the possibility that 3I Atlas is technological, and moreover, the calculations presented here are useful even in the interstellar object, or even if the other interstellar object ends up being a comet like 2I Borisov, because they could be applied to future detections of interstellar objects by the Vera C. Rubin Observatory over the coming decade. It's interesting.
Well, it is. There was more we could talk about, but I think that we will probably that's a good bit to understand and appreciate the anomalies and the enigmas associated with this thing. Questions again are, is this some really rare exceptional event that will only happen within the lifetime of human beings, or is it going to be something that's part of a new normal where we see these objects come flying in from the cosmic deep, who knows from where and who knows where they're bound, but they pass through our solar system. The one thing I was wondering was if something on the order of 20 miles or 12 miles in diameter, would that have the capability of disrupting or dislodging comets from the disk, from either the Earth, because of the fact that it's only 4 point something per angular inclination to the plane of the ecliptic. Well, that means it's going to be passing right through the Kuiper disk over a pretty long distance. Could the long-term effect be an object like this passing through the outer cometary zone, dislodge enough comets that it could then trigger a cascading infall of comets towards the sun, which could then lead to
all sorts of solar activity.
Yeah, solar activity, impacts on the internal planets. This brings us back to the Taurid meteor stream that we've talked about that could be so important, which appears to have been very important to our past and possibly again to our future, and deserves more in-depth discussion. We've certainly touched on it, but it would definitely warrant a more involved examination, because I think the potential is there for future impacts originating out of the Taurid meteor system. Even though it's old and diffuse, it is by no means exhausted. And so I saw some comments online, somebody saying we're going to potentially cross in 2032 but yeah, we're going to cross the Taurid meteor stream in 2032, but I got the impression they didn't realize that we crossed the Taurid stream twice each year. And I don't know why 2032 has been singled out. I don't think anybody has made a prediction that there's something we're going to encounter in that stream in 2032. Now, it could be that, most of the time when we pass the stream, we're going through areas where it's very low density clustering of meteoritic material. But there may be other places where it's not so diffuse, where it may be much more concentrated. And if we pass through the stream at that time in its cycle, then, the possibilities or probabilities of our planet being struck increase by some order of magnitude. And I think that's kind of one of the contentions of a number of scientists that have been working on the effects and the periodicities of impacts throughout the history of the Earth, and possibly now through the history of civilization on Earth. And there is more and more evidence accruing that, yeah, not only have Earth been pelted within the bigger picture of things over millions, 10 millions of millions, but also over the smaller scale from decadal, meaning like within a 10-year frame, up to centennial, meaning 100, or millennial, meaning 1,000. And within that framework of the human span of time, yeah, there could very well be a lot more impacts. But the point is that are the impacts from things from space, are they just come in randomly? Or are there what Victor Loeb and William Napier, I think, in their works refer to as an impact epoch or a bombardment epoch, where the timing is such that we are passing through meteor streams that have clustered or clumped, concentrated areas, and also meteor streams precess, just very much like the Earth. So there might be times when, if you're tilted at an angle, picture here's the Earth's equator. If we're tilted at an angle, and that's the stream, well, you can see there that the intersection time is short. However, as that angle gets closer and closer to being juxtaposed right upon the plane of the ecliptic, the more and more time those objects are going to spend within the zone of Earth's orbit, see? And if meteor streams precess basically like this, which it looks like they do, then there might be times when a meteor stream, which is now fairly well tilted to the Earth's orbital plane, may be laying very parallel to the Earth's orbital plane. Well, during a period like that, the probabilities of impacts are going to increase by some considerable amount. So it'd be worth talking about the towards the end, particularly because they do sort of show up now as one of the prime candidates for a multi-impact event at the lower Younger Dryas boundary.
We should do a series on the mythology behind the Taurids and the interesting history that they have. Yes. In the mythos of man.
In the mythos of man. Oh yeah. We find it in the kidnapping of Europa. We find it in the slaying of the bull in the Mithraic mysteries. We find it in Zoroastrianism. I don't know about Christianity, other than the fact that, the bull symbolism was very prevalent in cultures and civilizations that existed during the time that the spring equinox was passing through the constellation of the bull. And then it subsequently passed from the constellation of the bull to the constellation of Aries. And then you did have a lot of ram symbolism, like, New Kingdom of Egypt. You go there to Luxor, and you've got those rows of sphinxes with ram's heads, right? And then, then, of course, the vernal equinox passed from the sign of the ram into the sign of the fishes. And I think then we begin to see the fish symbolism so prevalent in Christianity. And I believe the early Christians were very sophisticated astronomers and had scientific knowledge that's kind of been an overlooked part of the study of early Christianity. I mean, we can talk about Egyptians having astronomical knowledge. We can talk about the megalithic builders of Stonehenge and Avebury as having astronomical knowledge. We can look at the builders of the monumental earthworks in North America and look at examples like Newark. Look at the Mayans. We see this presence of sophisticated astronomical knowledge. Well, there's not much conversation about the early Christians, but I would suspect that they did as well. And it showed up very much so in the building of the Gothic cathedrals. And that kind of archaeoastronomy was incorporated into the design of the Gothic cathedrals, these magnificent, glorious works of art and science together, which to me is what makes them so profoundly powerful, is this perfect fusion of art and philosophy and symbolism and science, which to me has showed me what I needed intellectually to appreciate Christianity was that there was this rational basis along with the faith. And so once I discovered that, I began to have a whole new appreciation for Christianity. And I think now when you bring up the bull symbolism, the foremost competitor to Christianity in the first century AD was Mithraism. And the bull symbolism was right at the heart of Mithraic symbolism. So, like you said, yeah, it would be very interesting to look at some of that stuff.
It'll be fun.
Yes, it'll be fun. To me, learning is fun.
Indeed.
Research is fun. So, I think this is probably a good place to wrap up this episode. And we'll be reconvening very soon, maybe before the week is out. We'll be recording another interview, discussing. I'm lining up some interesting guests to bring on in the next month or two. And then we
some real star power.
Yeah. Well, I did this. I did a sort of a tutorial yesterday with the folks over at 4RBs, and they're using magnetic forces in conjunction with restoring bee health and the robustness of the hive. And it's very interesting stuff. I'm just really on the beginning of learning about it. And we're going to record a whole episode where they show me how they're using these magnetic tools, not only just for bees, but for all kinds of things. Now, I've been using this, I injured my foot earlier this year when I took a tumble, and it's been very slow to fully get back full functionality. What I've been doing is I've been using this thing, setting it on a pillow on the floor and resting my foot, my heel, right on this magnetism. And we're going to talk about that because of the geometry in here. But what was interesting is it's based upon the overlap of 6 circles, starting with a single circle, the geometry of the hexagon, and then using each corner of the hexagon to draw a circle of equal radius, and that gives you this flower of life symbol. But when I did the interview with Terrence Howard, he showed me 3D models he had where he was actually, it was the same intersection of spheres as the circles that yield the flower of life. And what that does is it creates these zones of, he called negative, negative space. And he built a model of it. It's very, very interesting. And so coming right on the heels of that, I have this discussion with the people working on this and discovering magnetism forming geometric patterns. And the patterns seem to affect the intensity of the magnetic field. But I'm going to be learning more about that. Next week, I'm going to interview them. They're going to come on Squaring the Circle, and then it'll probably be a week or so, 2 weeks after that, by the time it gets cleaned up and we put it out. But just to let people know what's upcoming. And then November, the Azores trip, we're going in search of Atlantis, the word that we dare not speak, because if we do, we'll immediately be cast into the outer zones of the fringe and labeled as pseudoscientists, because only a pseudoscientist would even consider uttering that word. Atlantis. Did it exist? I don't know. Could it have? Yes, it could have. Based on what Plato describes, it could have existed. And I've talked about that a lot, and we'll talk about that more. Now, this isn't saying, because here's the thing. People get bogged down in this advanced civilization. What do we mean by that? Well, are we talking about crystal ray guns and flying machines and things like that? No, not necessarily, because he doesn't say anything about that, Plato. What we would be describing is potentially a very advanced, let's say advanced maritime or seafaring culture, not unlike the Phoenicians or the Minoans, but maybe, just more advanced from the standpoint of not necessarily technologically, but to the level of demographic or geographic range. It raises questions which I think are certainly worthy of asking. Is it possible that there have been seafaring cultures that had possibly even circumnavigated the globe that we've lost the record of? And we know for a fact that islands were being colonized 50,000 years ago, which implies some degree of seafaring capability, which then in turn implies some astronomical knowledge, because that's the key thing you need to know if you're going to navigate around the oceans of the world, right? So why is that such a huge stretch to go, okay, well, based upon what Plato is describing, he's describing a seafaring culture that had colonies, right? That to me is not so outlandish as now the fact that you have factions that have turned it into a subject of wooism or a subject of pseudo speculation, if you want to call it that, has served to give the archaeological establishment ammunition to essentially demolish or dismiss any discussion at all. I mean, I've seen people online saying that, oh, Randall Carlson, he has no credibility. He believes in Atlantis. I mean, almost literal quote. I've multiple times seen variations on that. Well, don't pay any attention to him. He believes in Atlantis, right? Oh, not exactly. It's a little more nuanced than that, dude.
Straw men are really easy target for cowards.
Yes, and that's what it is. And it's just too bad that even within the professional circles, we have intellectual cowards. And that's something we should talk about too, because there are examples of, where it's clearly a coordinated assassination attempt on people with unorthodox ideas.
Coordinated or even just an exercise in mob group think.
Sure. Yeah. Well, all right. I think that's a good wrap up for now. And
yes, sir.
I want to encourage everybody, go check out Ground News. And if you are a researcher and you want to keep up with current events, I don't think you're going to do better than that. And we will be continuing to use that as a resource here at Squaring the Circle.
Been enjoying it, really.
And enjoying it. Yeah, I've had fun with it. I really have. And I like those.
I'm glad they reached out as a sponsor.
Oh, me too. Yeah, me too. Absolutely. I mean, it was like I needed something like that, and I didn't know, because I'm like, there's just too much chaos trying to navigate around all the different sources on the internet to find what you're looking for. So putting this all in one place and then giving you these tools, these filtering tools, and these tools to discern where it's coming from and what the perspective is, amazingly helpful. So
check them out.
All right, John, once again, it's been fun. See you again.
You have a good night, sir.
I will.
ʻOumuamua.
ʻOumuamua.
Yeah,
ʻOumuamua. Okay, that's kind of like hunga tonga hunga. This is ʻOumuamua.
It is Hawaiian. I feel like I'm going to be put out to pasture every time I try to say it. So forgive me, native speakers. But yeah, that's going to be something we stumble over. And Borisov, 2i Borisov.